For this next problem, which is problem 6 in chapter 3, we'll be calculating KEQ and delta G naught for coupled reactions. So our question reads, for the process A goes to B, and this is a reversible process, so we have a KEQ. The KEQ AB is 0.02 at 37 degrees C. For the process B goes to C, KEQ BC is 1000 at 37 degrees C. Determine KEQ AC, the equilibrium constant for the overall process A goes to C, from KEQ AB and KEQ BC. That's part A. Part B says determine the standard free energy changes for all three processes. In other words, calculate delta G naught and use delta G naught AC to determine KEQ AC. So we're going to be determining KEQ AC two different ways, and make sure this value agrees with that determined in part A of this problem. Okay, so this sounds like a big problem, so let's get started. Alright, so let's remember that coupled processes are important for living things. So if we have a process that is unfavorable, if that process is coupled to a favorable process, then that will make the unfavorable process possible. And that's very important because a lot of processes go against the potential, and so they're needed to couple with a favorable process in order to occur. And so you'll remember Hess's law from general chemistry, where you add reactions together and get an overall reaction. That's what we're doing here. So we have PEP, or phosphoenol pyruvate, okay, plus water to give, PEP plus ADP, adenosine diphosphate, giving pyruvate and ATP. Okay, that's our overall process. PEP plus ADP yields pyruvate plus ATP. And this total delta G is negative 23 kilojoules per mole. Well, this is a favorable process because it is the additive process from PEP plus water yields pyruvate plus inorganic phosphate. That one has a delta G of negative 78 kilojoules per mole. And ADP plus inorganic phosphate yields ATP plus water. This one has a delta G of 55 kilojoules per mole. This one's positive. The middle one is positive. The top one is negative. But if we couple this positive process with the negative process, then we can get an overall negative process because we're adding things up. So the water cancels, the PI cancels, and we get PEP plus ADP yields pyruvate plus ATP. And so that total delta G is negative 23 kilojoules per mole. And since that one's negative, then the process will be favorable. So that's kind of what we're doing here. We have a coupled reaction. We have A and B and C, and we're trying to find AC. Okay, we're trying to find the equilibrium constant for A goes to C, and then the delta G naught for A goes to C. We're going to calculate the delta G naught, in fact, for all of them. Okay, so let's go ahead and get started. Okay, so we can say that this reversible process A gives B has a KEQ, and this was given of AB of 0.02 at 37 degrees C, and B goes to C. We've got a KEQ BC of 1000 at 37 degrees C. So the top one is going to favor reactants because this is less than 1, and the bottom one is going to favor products because this one is large. Okay, so if we couple these two reactions together, if we say A gives C, and if those are additive, then our KEQ may be favorable. Okay, or our delta G may be favorable. So we're looking for our KEQ for AC, and we want to calculate our delta G naught for AC. Okay, alright, so let's start with A. In order to give us the KEQ for AC, we're going to have to do some rearranging. So we can say the KEQ for AB, reaction AB, remember A, well, let me not write that here. We'll write it in a minute. Okay, AB is equal to B over A, okay, EQ. And that's for the reaction A goes to B. We'll just put that there. Alright, and so we can rearrange this to get BEQ on a side by itself. So we can multiply by A and divide by KEQAB. We can say BEQ is equal to KEQ times AB times AEQ. Okay. Now, the KEQ for reaction BC, and remember this is B, goes to C, is equal to CEQ over B EQ. So this is products over reactants, right? So B EQ is equal to C EQ over KEQ BC. Okay. And so what are we saying here? I'm saying that if BEQ is equal to this and BEQ is equal to this, okay, then this on the top, let's put a different color here, then this must be equal to this. Okay, so let's set those guys equal to each other. So I can say KEQ AB times AEQ is equal to CEQ over KEQ BC. Okay? Now remember, we're looking for KEQ AC. Okay, and what is KEQ AC? That's equal to C over A. Okay? Alright, so we need to get C over A on a side by itself. Okay? So let's divide both sides by AEQ and multiply both sides by KEQ-BC. Okay? So we can say that KEQ-AB from here, okay, times KEQ-BC from here, I got that, I multiply both sides by that, is equal to C over A, okay, and at equilibrium, EQ, okay, and that's actually what we're looking for. We're looking for C, we were looking for C over A. Let's get a different color here. We're looking for C over A because C over A is equal to KEQ AC, right? Okay, but if C over A is equal to KEQ AC, then this must also be equal to KEQ AC, right? So we can say that KEQ AC is equal to KEQ AB from here times, try to keep this as neat as possible, times KEQ BC, okay? And we have those numbers, so KEQ AB is 0.02 times KEQ BC, which is 1,000, which is equal to 20. So now we know that KEQ I'll just rewrite it. KEQ AC is equal to 20. Okay, so we've calculated that. So that was part A. It said, I can go back to the original problem here, probably easier. It said, determine KEQAC, the equilibrium constant for the overall process A goes to C, from KEQAB and KEQBC. So now the next question says, determine standard free energy changes for all three processes. In other words, let's calculate delta G naught for all three processes, okay, and use the delta G naught AC to determine KEQAC, which we did in A, and compare those values. Okay? So the next question is part B. Okay? So we want delta G naught for AB. That was our first reaction. Remember, that first reaction is A goes to B. So our delta G naught for AB, our delta G naught is negative RT ln of KEQ AB, and we have that, and that's equal to, I'm going to write it down here so I don't run out of room, which is equal to negative 8.314 joules per mole Kelvin times 310 Kelvin, which was 37 degrees C, right? 37 degrees C? Yeah, and then added that to 273 to get 310 Kelvin, and then ln of 0.02. Okay, that's our KEQ. Alright, and so that, if you add that up, that's 10.1, if you convert that to kilojoules. So that would be 10,100 joules per mole, okay, which would be 10.1 kilojoules per mole if you divide by 1,000 to convert to kilojoules. Okay, so next we have delta G naught BC, which is equal to negative RT ln KEQ BC, which is equal to negative 8.314 joules per mole Kelvin times 310 times ln of 1,000, which is equal to negative 17800 joules per mole Kelvin, which is equal to negative 17.8 kilojoules per mole. Alright, and we calculated KEQ for AC, so we can calculate delta G naught for AC the same way, negative RT ln KEQ AC, which is equal to negative 8.314 joules per mole Kelvin times 310 Kelvin times ln of 20, which is equal to negative 7.72 kilojoules if you go ahead and divide by 1,000 per mole. Okay. Alright, so the next part says to calculate delta G naught. So we also know that delta G naught for AC is equal to delta G naught for AB plus delta G naught for BC, okay, and that is equal to 10.1 because we just calculated that, plus negative 17.8, which is equal to negative 7.70 kilojoules per mole. Okay, because we just added those numbers up that we just got, and that's the same number that we got earlier. Okay, so we were able to calculate that two different ways. So this is roughly the same number. Okay, so we got our delta G from our KEQ that we calculated, and we got about the same number as the delta G we got from adding the delta G's for each process. Alright, and so overall this is going to be a favorable process because it has a negative delta G. So that was problem 6. Thanks for watching.